Okay, so what I'm going to do is play the video I made of me doing the lab. And as we go through it, I am going to do the math on the left-hand side here. So usually in class, we would do this lab, obviously. And the one good thing about this lab is it actually forces you, like you can't do the lab without doing the calculations. So I highly recommend that if you prefer to print stuff off and put it and write it out as we go along, then pause this video and go print the preparing solutions investigation worksheet off. Even though I didn't make you hand it in, it's good practice for these types of calculations, which will be on your assessment. Okay, if you haven't watched the calculating concentrations video, the last example, or the preparing solutions video from the last time we were together, like Friday, January 15th, then pause this video totally and go back and do that, okay? Because this is an application of those items. So you can see here in this video, I've got a solid. So it is sort of like a cooking video. I had to weigh the solid at school because I don't have a scale at home. So in order to do this lab, you would need to prepare the solution. You have to calculate the mass of solid first. So when you're calculating the mass, you're going to do two things. Or sorry, you can do two things. You could do the first way would be to do the new triangle from this unit. Concentration is moles per liter. Then change it to mass using this formula or triangle from the quantities unit or dimensional analysis if that is your thing as well. Or you can use the combined one that is talked about in the preparing solutions video again, which is from January 15th. Okay, so when I do the calculations, I'm going to show you both ways, both triangles here, or both ways to do this. It doesn't really matter which one you pick. So when you're making a solution, if you're starting with a solid, the scale measures grams, we need grams, but also we need to take into account the molar mass or molecular weight, and we have to look at what concentration we want our solution to be. So again, you're not just throwing some solid in with distilled water. It is quantitative, which we don't focus on when you're in younger grades, but now that you're seeing the value in using more quantitative measures, then that's what we're focused on moving towards, okay? So you're given a variety of pieces of information here. So the solid we're talking about is CuSO4.5H2O, which means, again, copper 2 sulfate pentahydrate, right? That's a hydrate. So we need to include the mass of the molar mass of water in our calculation for number one. Then we are also told that it needs to be 50 milliliters, and the concentration, which is big C, is 0.500 moles per liter. Okay. So let's go through this in order. We're going to calculate the molecular weight or molar mass of the solid. So again, decide how much work you need to show. So we're going to do 1 copper, 1 sulfur, and 4 oxygens. And then we're also going to add in 5 waters. Or when you do hydrates, if you're the kind of person who likes to do 10H plus 5 oxygen separately, you can certainly do that as well. Okay. I'm going to leave the units out in my calculation just so I don't run out of room here. So we have copper is 63.55. Sulfur is 32.06. Oxygen 16. And water, again, maybe some of you have memorized, is 18. And then the units are grams, Oops. Grams per mole. Okay, so maybe you're good at this at molar mass now and you would just write down the answer. That's totally fine. Maybe you're even good at this that you would just normally in a question like this, if it was just a paper and pencil task, you would go right into the calculation of the mass, knowing that you had to find the molar mass of the solid. That's fine too. Okay. So when we are going to calculate the mass of the solid, again, I'll show both ways. So I'll do method 1, that's at the top there, and I'll do method 2. What you're going to see is that we're going to get the same answer, obviously, and it really just is personal preference. Okay, so when you have concentration, so the concentration up here is moles per liter, so that means that our volume is liters. So right now we are given the volume as 50, and in order to get to liters, it's milliliters divided by 1,000. Okay, so again, there is an advantage there to using dimensional analysis because the concentration is given as moles per liter. So then if you want the liters to cancel out and be left with moles, then you're going to multiply and they would cancel out. So keeping the units in your calculation can help maybe. It kind of depends what you prefer, okay? So the first method that I wrote down was to use the formula from this unit, that concentration is moles per liter. So the concentration is given as 0.500. What they're trying to show is that that's a very exact concentration by including those zeros. Technically, when we do the math, that's not going to matter. So if you don't want to write them down, that's fine. You can do that. We don't know what moles is. That's what we're trying to find. And we've got 0.050 liters. So again, when you do dimensional analysis, now you can see that the 0.05 is in the bottom. Dividing, the inverse operation is multiply. So we have to multiply on both sides. And that when you multiply, the liters are going to cancel. You're left with moles. Okay, so that certainly is one way to do it. So 0.05 times 0.5 is 0.025 moles. Okay, now we need to change that into grams. Our scales do not measure moles, so this would be in a practical way. Now we're going to measure the gram amount. So again, whether you use the triangle, use the mole version of the formula and sub in numbers, it doesn't matter, you're gonna multiply. And I'm kind of running out of room here, so we already calculated the molar mass. So again, if you were doing this without being prompted to separate it like this, maybe some of you would just put the molar mass right in the calculation, which is fine, okay? All right, so there's one way we can do this. Oops, I wrote a 2 there, maybe. It's more like 1A, 1B. So then for number 2, that's this big triangle here from this unit. It's really just combining the other two. So if you look at mass, then if we're looking for mass, then what you're going to do, you can see, is multiply C times MW times V, because they're all in the bottom. Which, let's say you were going to be a SciTap student, this might be how you would want to write the formula. Okay, gonna run out of room here, so I'm not gonna put in the units, sorry. 0.05 liters and times 249.61, which gives you 6.24 grams. Okay. All right, so you would measure out the 6.24 grams. You can see in the video on the right-hand side that that's there in the beaker. So it's hard to see because of the glare of the sun, but you can kind of see the blueness of the solution. I'll tell you why when we do the second part, why I chose a solid that was blue. Normally our solids are white, but copper 2 sulfate pentahydrate is blue. Okay, so I've got 50 milliliters. Of course, it is distilled water. And I'm going to cheat and use a hot plate to get it to dissolve. Normally, if we were in class, I would make you stir. But I am going to cheat and use a hot plate for the video's sake, so it's not too long. And heat up the water a little bit to get the solid to dissolve faster. So I'm stirring to get it to dissolve. And now you can really see the nice blue color of the solution. So if we were in class, I would ask you to make the solution, and you would actually, I would mark your solution, like you would keep it, you wouldn't throw it away. So it says number 4, use distilled water, prepare your solution. We did that. And then number 5, it says label your solution with the correct formula and the molarity or the concentration. So molarity is another word for concentration if you want to, right? Because concentration is moles per liter. So sometimes we call that molarity because you can't leave beakers. I mean, this is nice and blue, so maybe people would infer what it was, but you can't just leave stuff hanging around without telling people what it actually is. So we have the nice blue solution. If we were doing this in class as well, I would measure out the 6.24 grams and actually, you would measure it out, and then I would come and look at the scale and make sure that you had measured it correctly. So you would be actually given marks for your procedures during the lab. So safety first, I unplug the hot plate. I didn't want to put it on my table when it's too hot, but it didn't take that much heat to dissolve. Okay, got out my Sharpie and my green tape. Double checked. Most people put the symbols. You could certainly write the words copper 2 sulfate pentahydrate, but most people choose to label their solutions with the chemical formula. But of course, the concentration is important. So even when I'm asked to make a solution for, say, a grade 10 class or whatever, I ask them, what concentration do you want it to be? Put it on the beaker. And then, like I said, if we were in class, you guys would leave that at the side and I would mark that as well. Okay. So now part 2 is making this solution more dilute, okay? So again, if you haven't watched the dilution video yet, go back and make sure you do that. The dilution formula is C1V1 equals C2V2. 1 implying more concentrated, and the 2 side implying dilute, like 2 is later than 1. Because in a quantitative way, if you want to make a solution that's less concentrated or more dilute, you have to take an amount of the more concentrated solution and then add water to it to make it more dilute. Could you go backwards and take water out of the solution, evaporate it, and then get back your concentrated solution? Theoretically, yes, but not really in a quantitative way, right? So that's not usually practically what we do. So we're going to look at, usually, and this is, again, if you're interested in SciTap or whatever, this is usually what we would do. We would have a more concentrated solution. You would calculate the amount or volume of that solution we're going to take out and how much we are going to, in order to make a solution that we know we want, what we want the concentration to be and what volume we want to be. How much do I need to use during a lab or whatever. So this is, as much as you don't necessarily usually make a series of dilutions like this, doing this kind of dilution is a common thing. So what you'll find is if you continue in chemistry, sometimes you have to do these kinds of calculations and we haven't even started, you wouldn't even have started the lab that's pertinent to your topic yet. So maybe you have a concentrated solution and you need to make a variety of less concentrated or more dilute solutions in order to do your lab. Okay, so here, this little picture, you can see it sort of looks like the video, right? I don't know how gradient I can get here, but we have a nice blue solution that is 0.5 molar. And then we're going to make a series of dilutions. So it says, number one, you need to prepare a series, okay? First, you will be diluting your 0.5 molar solution. So initially, this is the concentration that's more concentrated to make 25 milliliters of a 0.2 molar solution. So in this first case, in dilution number one, I'm going to call it, we want our concentration to end up as 0.2, and we want it to be 25 milliliters. Okay? But what we don't know is how much of the 0.5 do we need to take out to make 25 milliliters of 0.2. And this is really, I do this all the time, okay? So that 0.5 to 0.2 is not quite half, okay? So that's going to matter if you're the kind of person who likes to think about the logic of your calculations. So then the next, so this is dilution number one to make 0.2. Okay? Then number two, sorry, I'll fix that, it looks terrible. Do it again. Then number two, we are going to now take this solution. So we're going to we'll be done with the 0.5. We want to take from this one. So it says, then you will dilute the 0.2 molar solution. So now this solution is going to be C1. And to end up as 0.1, and the second volume is always going to be 25. Okay, how much of this solution do we need to make this one? So we're going to calculate a new V1. Just so it stands out, I'm going to use a different color. 1, so this is calculation or dilution number 2. Then dilution number 3. We're going to take the 0.1, which is now going to be our C1, and we are going to add some of it. How much? We don't know, because we want our C2 to now be this, 0.05, and V2, of course, is still 25. So this is dilution number 3. I forgot to label this. 2. And then the fourth one, we're going to take 0.5 and make it 0.025. So now this is going to be C1. okay? So in order to do this, we need to calculate V1. How much of each solution do we need to take, okay? So C1 V1 equals, put a number 1, C2 V2. The first concentrated solution we're starting with is the one we just made. We don't know how much of it to add. We know that we want to end up with 0.2, which is 25 milliliters. So every single V2 is 25. So what I'm going to do is I'm just going to write that over here. The dividing, okay, to change it to liters. So the math you're going to do every single time is divide by C1, like the V1 is your X. So V1 is 0.2 times 0.025 divided by 0.5, which gets you 0.01 liters, which unfortunately our graduated cylinders do not measure don't measure liters. So if this was a paper pencil task at the test, you could just leave it like this. But because we're going to actually do this, then you want to multiply by 1,000 to get it back to milliliters. Okay. So we would take 10 milliliters of the first solution and make our new solution. Oh, wait. It does talk about the water. So if you want, I'll change to blue maybe here. So if we want the final volume to be 25, but we have 10 milliliters of solution, then we're going to add 15 milliliters of water. It's just subtracting. So unlike the solid, which by definition, solids have to fit in between the water molecules, you don't change the volume. Whereas with a solution, it is going to change the volume. So again, if you haven't watched that preparing solutions video, go back and do that, okay? Because practically that's an important difference. All right, so let's watch me make my 0.2 molar solution. So normally in class, I would encourage you to use 2 different graduated cylinders, and mostly 2 because you have 2 partners. But here I only have 125. So I'm going to do it in both the water and the solution, but normally I wouldn't do that. Okay, so we have 10 milliliters of 0.5. Put it in a test tube. And then measure out, I also should have brought home a pipette, measure out as close as I can, 12.5 milliliters of water. I had to dump a little bit out in a waste beaker. Pour it in. And now I have added water to the concentrated solution to make it more dilute, okay? So this new solution in the test tube is now 0.2 molar. Okay, so now let's do the calculations for number 2. Okay, so dilution number 2, now the C1 is 0.2. Again, how much do we need? I don't know. So you can see that I did not use the beaker anymore. Now I'm taking from the test tube I just made. And then that's how you get the series of dilutions. Okay, so then what am I trying to make? This time I'm halving it, so 0.1, but still 25 milliliters. And you do the same thing. So you're going to get rid of the 0.2, you divide by 0.2. Again, that's not practical. We get 12.5 milliliters. For the water, 25 minus 12.5 is 12.5. So this happens because we're halving it, right? We're halving the concentration, so we're going to use half of the volume. And I put it in a new test tube. So right now they're the same concentration, but then I add the 12.5 milliliters of water. I think I said in the first one I added 12.5 milliliters of water. I meant 15, sorry. Okay, so now we have a test tube that is 0.1 milliliter, 0.1 molar. So you can see that the blue color is starting to become less intense because it is less concentrated or more dilute, which we should continue to see as we start to decrease the concentration by half each time. Okay, so now let's continue and do dilution number 3. So now C1, if you look at number 3 up in our picture, C1 is 0.1. Our C2 is 0.05 and 25 milliliters. I'm really running out of room now. So I'll do 0.05 times 0.025, push equals, and divide by 0.1. And again, you get 12.5. So you get 12.5. Actually, you get 12.5 because you're halving it. So even though sometimes students are frustrated because they're like, it's the same as the other one, but it's because we've halved the concentration. So you're going to get the same because you're halving it again. Remember, we're always starting from the tube before, okay? So now I'm taking some of the 0.1 tube. I've got the graduated cylinder turned weird. It's got calibrations on both sides, but it is 12.5. of water. to get us to 0.05. And show you now, you can really start to see that the tubes are becoming less blue. Okay, last one. Our final dilution, we're taking the 0.05 and changing it, halving it again to 0.025. Sometimes this messes students up as well because the volume and the concentration are the same, but that's okay. So 0.025 times 0.025 divided by 0.05 gets us, what a shock, 12.5 milliliters. Again, because we are now halving the concentration again. It's supposed to be minus, sorry. Okay. And now we're at 0.025. So when I show you the difference in the color, you'll see that the last one is almost white, or sorry, almost looks clear. So the last part there, so again, if this was in class, you guys would have left your tubes and I would have marked the tubes as well. So you can see that the most concentrated is very dark blue, and then as the concentration decreases, so does the blue color. All three of the first tubes are the same height. They have the same volume because we took from those. We took 12.5 from those, whereas the last one we didn't because we were done. Okay, so that's why it has more. We didn't take 12.5 milliliters from that. Okay, so it says number 3, it takes 5 test tubes. We did that. Order your test tubes from highest to lowest concentration. So the highest concentration would have been the original 0.5 solution. And then as you went along, then the lower the concentration was and the blue color decreased. So that's why I use the blue copper 2 sulfate pentahydrate, because it gives this nice color so that you can see the change in concentration. You can actually see it. So normally, or up until now in your chemistry lives, you've probably done more qualitative stuff, where now we're trying to switch to quantitative. And instead of saying blue is more concentrated, we're going to say 0.5 is more concentrated than 0.2. Okay, thank you.